For this demo, we're going to be using an Arduino and an Arduino Ethernet shield and nothing else. I'm going to show you how to set up a basic reporting web server on your Arduino. A look at the simple web server from one of the examples that come with the IDE. In demo 2, we'll make a few changes to it so that it reports data from a humidity temperature sensor and a photoresistor. In this demo, I'll show you how to set up a basic reporting web server on your Arduino. We'll look at the simple web server from one of the examples that come with the IDE. Then in the second demo, we'll make a few changes to it so that it reports data from a humidity and temperature sensor and a photoresistor. So let's go ahead and load up the example sketch. I'll go through examples and Ethernet and web server. I'll go ahead and plug the Ethernet shield onto the Arduino. Plug the Arduino into my computer and plug the Ethernet cable in. I'm not connecting any sensors. I'm just going to take readings which are going to be basically random values in the analog pins of the Arduino. So here's a sketch. Let's upload it and see what it does, and then we'll discuss how it does it. Oh, but before we do that, I need to adjust the default IP address to match that of my network. So I'll go ahead and make the change and upload it again. Okay. Check out the monitor. So the server is now available at this IP address. So I'm going to copy this address and use my web browser to access it. Okay, there you go. So the web server responds by printing out those random values at the analog input pins. And every 5 seconds, my web browser is sending the same GET request to the web server so that the web server sends back updated values from its inputs. So that's all it does. Now, let's have a look at how it does it. The first part of the sketch is identical to what we saw in the previous lecture. So we simply include the libraries that we'll be using. We set up the MAC address and default IP address. And then we go ahead and create the server object using the Ethernet server class of the Ethernet library. The only difference between this and the previous example in the previous lecture is that now we want to set the server to listen in port 80, which is a default port for web servers. And let's go into the setup function. We start up the serial port so we can get output from the Arduino. Then we call the begin function so that we can contact the HTTP server and acquire an Ethernet address. And we start the server and print out the IP address so that we know what it is and know where to send our GET requests in a minute. Now all the action is happening in the loop function. So first we check to see if a client is trying to connect, and if it is, then we start processing that request in this block in here, inside the if client block. So print a message. Now the interesting thing is starting to happen here. This is where we are starting to deal with the parsing requirements of a GET request. Now what happens is that whenever a web browser sends a request, it could be a post request or a get request or whatever other kind of request, the web server sends out information in a particular format in accordance with the HTTP rules. Now, if we look at the monitor, we'll see, I'll let it run the next cycle. All right, we see that here we've got the information that our web client is sending to the web server. Just copied that. Oops, I'll try again. Just flies. Stop auto scroll and grab this so I can explain what it's all about. Okay, so this is the GET request that the web server is sending to the web client, and you can see that it starts, the very first line is the verb, the HTTP verb. When you type a URL into a web browser and you hit enter, then that is called a GET request, and it's signified by the verb GET. If you were submitting a web form, then possibly you will be using a POST request. So the first word that the web browser would send to the web server in its request header would be the word POST, the POST verb. So at the moment we've got GET. We'll talk about POST later on. What we've got here is that the resource that the web client is asking from the web server is this, favicon.ico. And then there's a white space. Then we've got the version of the HTTP protocol that we're using, 1.1, and then a bunch of other types of metadata. So we've got host, kind of connection, and so on. Now, I'm going to use or show you how to use a tool called request bin. With request bin, we can disassemble HTTP requests and see what's inside them. So a very useful tool to have in mind, not just for Arduino development, but for any kind of web development that you might be involved in. You go to request.b.in and you create a new request bin. And what you get back is a URL. So you can then use this URL to send your HTTP requests to. So let's have a look. I'm going to copy this URL, create a new tab in my browser, and paste it. And just hit enter. And that's going to generate a GET request. It's going to go to request bin. Request bin is going to send back a confirmation. Okay, it received the GET request. Then I'm going to go back to the original. Notice that there is a inspect instruction here, and refresh it. Now you'll see that request bin received a GET request from a browser, and these were the parameters of the GET request. Basically, we asked for this particular resource. Another interesting thing to look at is that I can do the same request, but now pass parameters using the question mark delimiter, and I can say, for example, a equals 1 and b equals 2. Send that request over. Again, I get an OK confirmation. Then refresh my request bin page, and you can see now that here's my GET request with the GET verb. The resource that I requested is this, and then I'm setting parameters. Here's b2 and b equals 2 and a equals 1. There's also the query string is broken down like that in value pairs, and then I've got the headers with all the metadata that my web browser sent. And another nice trick that you can do is in the Chrome browser to use the inspect element facility, which is a very, very useful feature in this browser. So bring it up by selecting inspect element after you right click anywhere on the window, and then click on the network tab, and this is what you get. Now if I refresh or resubmit my request, I get a new row here. If I drill into it, you'll see that I get information about my GET request. Now at least for our purposes right now, the interesting part of all this is the request headers. As our view source link, you click on that, and this is just the raw GET request containing all the text that the browser sent to the server. Here's the verb that the browser used, the resource that was requested, and the key value pairs that are sent over as part of the URL, the GET request. Now, another important thing to remember as you're parsing all this is that the Arduino now is going to have to extract the information that it needs in order to figure out what the browser is asking for. And once it figures out what it's asking for, to do it and send back a response. So the Arduino will have to inspect or read or parse all of this text. Now we are lucky because what we need is in the very first line. And you can see that the very first line contains again the resource that was requested and the key value pairs, and then it ends with a white space. Now the whole request finishes down here. It's the last line. The last line contains a new line character. It's invisible, but it's here. And after that, we've got another blank line. So the HTTP protocol stipulates that a request, whether it's POST or GET request or whatever it is, finishes with a blank line. So essentially, we are looking for 2 blank lines. So let's go back to the sketch and see how all that plays together. So once we have a client connected and available, meaning that it's still sending data to the server, then go ahead and read out what the client has to send. And just like we saw in the previous lecture, we can only read each character one at a time. So as say characters arrive from the client, we just grab each one of them, read them, and then deal with them. The next thing we do here is to print it out into the monitor so we can have a look and inspect it. So that's how all this text was generated. It was generated one character at a time. And then we make sure that we are still receiving text characters from the client. We know that we're no longer receiving anything if we encounter both a new line and the last line we read was blank. So it's in the monitor, it's the situation here. We have a new GET request sent over. You can see here that we've got a blank line. And after the blank line, we've got another new line, empty character, which when these two come together, it signifies the end of the HTTP request. So if the request has completed, then we go ahead and we send out our response. And the response is happening here. So what the response is this information that the server then sends back to the client. And this is just the response headers part of the response. It's just the first few lines of information that the web browser needs in order to, first of all, know that its request was successful. And then things like what kind of content is the server going to send me? And that's, in this case, it's text HTML. and then the response itself, the response body itself, is normal HTML, which we can look at. Sorry, I'm looking at the wrong thing. So normal HTML, which looks like this. Now this is again generated by the Arduino here. So the first 4 or 5 lines make up the response headers of the server. Just says that, yeah, we got the message, it's all okay, and we're using HTTP version 1.1. We're going to send you back HTML document, and we're going to close the connection. And this is our piece of non-standard HTTP instruction, which says refresh. It's an instruction to the browser saying, please refresh yourself every 5 seconds so you can get updated readings. Once it's done, then we print out a blank line. Very important. HTTP protocol stipulates that after the headers are sent and completely delivered, then print out a blank line before you start delivering the body of the response. So then we have a HTML document constructed line by line. We'll start with the header, and here we just go through in a loop. We go through the 6 analog pins. We grab any values that I have and print them out into a HTTP document response. Once we finish with constructing the document, we break out of the loop. So we break out of the while loop so that we can close the connection by calling the stop function. We also insert a delay here for 1 millisecond. It could be 10 milliseconds in order to give enough time to the client to receive response. One question I haven't answered yet is how do we know that the current line is blank? Okay, so now imagine that we are, say, at this point of, or this character of reading the HTTP request from the client. We are progressing through it. We still have things to read, but we haven't received yet a current line is blank being true. So that will become true if there is a particular condition. In this case, if we encounter a character, a red character being new line, so this is a special invisible character, in that it doesn't have something that we can see in the monitor. It's invisible. So if it's a \n, special character meaning new line, then the current line Boolean variable is true. If it's anything other than that, then it's false. So if we happen to have current line is blank and another new character, so 2 in a row new lines, then we know that the condition is met to confirm that the HTTP request header has completed sending itself and being read. So we can go ahead and send our response back. So I hope all this makes sense. It's best to also read the notes. Try to make it a little bit more clear in the notes. So have a look at the notes. And if any of this doesn't make sense, feel free to ask.